Hey guys, Miss Miklos here with our final lecture of this chapter. Today we're talking about our favorite concept, word problems. So I know that we are all excited about that. But we're actually just going to go through one example because the key thing here, we're not really doing anything new. We're just looking at this problem and trying to figure out what are my variables, what are my equations, and then going about solving it. So some things that we need to remember is that in this chapter, it would make sense that I have to deal with three variables. And we know if I have three variables, in order to solve that, I need to have three equations. Sorry if you hear meowing in the background. My cat is going crazy for some reason. Anyways, for this particular problem, let's just kind of look through it. In a coin bank, there are 3 times as many dimes as there are nickels and quarters combined. The total value of all 24 coins is $2.90. So some things that I kind of already figured out there. Just to be fun, I'm going to use N is the number of nickels. D equals the number of dimes. And I'm going to let Q equal the number of quarters. So once again, if I really wanted to use X, Y, and Z, I can. Okay, but for this problem, I thought N, D, and Q might help me out a little bit. So some things that I'm trying to figure out here. First, it says that there are 24 coins altogether. So my first equation is going to be N plus D plus Q is equal to 24. It also tells us that the total value is $2.90. Now, I personally don't really like working with decimals, just like I don't like working with fractions. So instead of putting like 0.05 times n, and the reason why I would choose 0.05 is because I know that's how much a nickel is worth, I'm going to go ahead and say 5n plus 10d plus 25q equals 290. So basically what I did, I took that entire equation with the decimals and I multiplied it by 10 to change it. My final piece of information is that there are 3 times as many dimes as there are nickels and quarters combined. So that's telling me that the number of dimes, so D, is equal to 3 times N plus Q. Okay, or I could also think of this as D is equal to 3N plus 3Q. It really doesn't matter. So right now I have my 3 variables, I have my 3 equations. Okay, I have number 1, number 2, and I'm going to use this one down here as number 3. So we need to figure out how we want to go about solving. And so far we've really learned linear combination and we have also learned Cramer's rule. I'm actually going to teach you a third method today, substitution. Okay, and with substitution, the reason why I'm thinking that might be helpful is because this third equation already has D isolated by itself. So I just went ahead and rewrote out our problems. And what I'm going to do is I'm going to take this value for D and substitute it into D into our other 2 equations. So what that gives me is N plus 3N plus 3Q plus Q is equal to 24. In my other equation, it would give me 5N plus 10, 3N plus 3Q, plus 25Q equals 290. So let's just simplify. I would get 4N plus 4Q equals 24. My other equation, I would get, when I distribute, I would get 30n plus 5, so 35n. And I would have 30q plus 25q, so plus 55q is equal to 290. So I have two equations now that both have two variables. Right now I just have n and q. So we can solve this 2 by 2 system using whatever method we want. I'm going to stick with substitution. So I'm going to isolate this n here. So I'm going to do 4n equals 24 minus 4q. So n is equal to 6 minus q. So in my other equation here, I'm going to write 35 times 6 minus q plus 55q equals 290. When I distribute, 35 times 6 is 210 minus 35q plus 55q equals 290. So 210 plus 20q equals 290. 20q equals 80. So q is equal to 4. Now, let's think about it for a second. It would make sense that I have a positive integer because I know I can't have a fraction of a coin. I also know I can't have a negative amount of coins. So now that I know how many quarters we have, I need to go ahead and I'm going to substitute it into this other equation to figure out how many nickels do we have. I have 6 minus 4, so our number of nickels is 2. To figure out my final variable, I'm going to substitute back into one of these three equations. I'm actually going to use the one that's already isolated for d, but it really doesn't matter. So I'm going to say d equals 3 times 2 plus 3 times 4. So d equals 6 plus 12, which is 18. So what I'm saying here is that I have 2 nickels, there we go, 18 dimes, and 4 quarters. Now, let's just kind of think about that for a second. Does that add up to be 24 coins? 2 plus 18 is 20, 20 plus 4 is 24, so that's good. Is 18 3 times as many as these combined? So this would be 6 times 3, which is 18. And the final thing is, does this add up to be $2.90? So let's look at it. This would be $1. 18 dimes would give me $1.80, so that would be $2.80. My nickels would add another 10 cents, so I get $2.90. So I know that this is my solution to my system.